Alright, today we're going to start with our last two gas giants and our last two planets in our solar system. First up is Uranus. Uranus' rotation lasts 7 Earth hours and 14 minutes, and its revolution lasts 84 Earth years. Uranus has an axial tilt of 97.7 degrees, meaning that it's basically tilted on its side. Because of this tilt, Uranus makes for weird seasons. The planet's North Pole experiences 21 years of nighttime in the winter, 21 years of daytime in the summer, and 42 years of day and night in spring and fall. Like Venus, Uranus rotates in the opposite direction than the other planets, so it rotates from east to west. Neptune was first discovered by the modern telescope. Its discovery was credited to William Herschel in 1781. Originally, he thought it was a star or a comet. The temperature on Uranus' surface is negative 210 degrees Celsius, which is negative 346 degrees Fahrenheit. Uranus is known as the coldest planet in our solar system. Uranus' color is due to the absorption of red light by the atmospheric methane. The Voyager 2 is the only spacecraft to fly by Uranus. No spacecraft has ever orbited this planet to study it up close. Next up is our last planet, Neptune. Its rotation lasts 16 hours and 6 minutes, and its revolution lasts 165 Earth years. The surface temperature on Neptune is negative 200 degrees Celsius, which is negative 328 degrees Fahrenheit. Neptune has 14 known moons, and it is also known as a blue planet. This is due to the amount of methane that's within its atmosphere. Neptune was the first planet to be discovered purely based on mathematical prediction, rather than by direct observation. Since its discovery in 1846, Neptune has only completed one orbit of the Sun. The Voyager 2 is the only spacecraft to have ever visited Neptune. No spacecraft has ever orbited Neptune. Now we're going to talk about a major part of our solar system, the Sun. Another name for the Sun is Sol. The Sun is the center of our solar system. It makes up 99.86% of the total mass of our solar system, which is why our planets are able to orbit around it. It is made up of hydrogen and helium. The Sun is brighter than 85% of other stars within our Milky Way galaxy. To finish off our lesson today, you're going to be watching a short video on comets, meteors, meteorites, and meteoroids, and what the difference between all of those things are. Remember that a meteoroid is in space. It's usually broken off pieces of asteroid or comet that are floating within space. A meteor is when that meteoroid has entered Earth's atmosphere. This is also what we see as shooting stars. And a meteorite is a meteoroid that has survived the passage through Earth's atmosphere and lands on Earth's surface. Remember that rarely ever happens because of the layers of the atmosphere that it would have to go through and have to survive through.
Let's start with comets. Comets are basically big balls of dust, rock, and metals surrounded by a thick, icy shell orbiting our sun. And when comets get too close to something hot, like the sun, their ice sublimates, or goes instantly from a solid to a gas. This creates a halo-like glow around the comet, called the coma. And our sun's strong solar winds blow the coma back, giving the comet their infamous tail. Comets can be classified as either long period or short period, depending on whether or not their orbits are longer than 200 years. Comets have highly elliptical orbits, which means they're like a long circle. In fact, some comets can be taken almost completely out of the solar system before they return again. Then we have meteoroids. Meteoroids are just pieces of rocky space debris floating around the solar system. Technically, meteoroids are larger than a grain of dust, but smaller than an asteroid. However, most meteoroids are usually only the size of a pebble. Most meteoroids also come from the asteroid belt, but some do come from our moon or even Mars. Next are meteors. Simply put, meteors are just meteoroids that actually hit Earth's atmosphere. We know these better as shooting stars. As a meteor hits our atmosphere, it burns up, causing a big flash of light in the sky. In fact, the term meteor from ancient Greece literally means celestial phenomenon in the heavens above, which refers directly to the flash of light itself. Even though they appear as big shooting stars, meteors are actually only the size of pebbles. Last but not least, meteorites. A meteorite is simply a meteoroid that successfully makes it through Earth's atmosphere and hits the Earth's surface. Meteorites are dangerous simply because they're too small to be detected. They come without a warning. And even though meteorites are usually very small, around the size of a pebble, they're still very dangerous because they travel at high velocities. Fortunately, it's very rare for a meteoroid to actually make it through Earth's thick atmosphere. Thanks, Earth!
Alright, so that's it for today. Next week we're going to try a little bit different of a platform for our optional digital learning. So just make sure that you're keeping up to date on Remind and listening out for announcements on how that's all going to work. Love and miss you guys.